right, let's look at example 3. Understand closure. Is the set of polynomials closed under addition or subtraction? Explain. The set of real numbers is closed under addition because if A and B are real numbers, if you add them, C is also going to be real, right? So by closure, it means is it still going to be the same set as your numbers in the beginning. So AB plus added together will still result in a real number, right? If it's real, you add real numbers, you get a real answer. So it's going to be real. It's closed. If you add two polynomials, is it going to be closed, right? So in this sense, we're going to check if it's still going to be polynomial, right? So it's a type of number or type of thing that we're going to look for. So if your answer is still, if you're adding two different things and it's still the same as the things you added, then it's closed. If you get something different from a different set of numbers, then it is going to be open, like it's not closed. So it's not closed. So let's see if any polynomials would add up to polynomials, right? So let's assume that a sub n times x to the nth power, because polynomial in standard form will have the greatest number n for your first term, and then your second term will be the next greatest number, and then the next one, and so on until you just get the constant term, a sub 0. Okay, so your constant term, we're going to label it as a sub n and a sub n minus 1, a sub n minus 2, and so on, until we get a sub 2, a sub 1, and a sub 0. Okay, if it's a trinomial, it's just going to be a sub 2x squared plus a sub 1x plus a sub 0. Or if it's a trinomial that is missing the middle term, then it could have a higher degree. It just means that your constant is 0. But anyway, this represents any type of polynomial you have. And then we can also write another polynomial that represents another polynomial with a different constant, right? And we can represent that using b sub n and b sub n minus 1 and so on. So if we add them, the first term will just be a sub n plus b sub n times x to the power of nth power, right? Because they're going to be like terms. So a sub n, whatever a sub n is, it could be 1, it could be 2, it could be root 2. We don't know, but it's real numbers. And if we add this with b sub n times x to the nth power, then if a sub n is 1, b sub n is 2, then if we add 1 plus 2, it's 3x plus x to the power of nth, right? So we just add them and we still multiply it with the x, but we're not going to be able to multiply further because they're going to be constant and the variable. So you just leave it as a sub n plus b sub n times x to the nth power, and it's the same for all the other terms, right? So it looks a little bit complicated to look at it in all letters and variables that represent actual numbers, but but if you understand that a and b here are constants, that could be just any numbers, and the x is the variable we have right now. We can represent two polynomials, and the addition of those two polynomials would still be polynomials, right? Because it's a real number with a constant as a constant, and then we have the nth term. So a, b are real, and a plus b would also be real, and the exponents are still going to be the same for each term. It's still a polynomial, right? So it's still ends up with being a polynomial. This means it's closed under addition. So using the same logic, can you determine that the set of polynomials is closed under subtraction? So that's try number 3. Is the set of monomials closed under multiplication? Explain. So let's answer this one first, right? Using the same logic, you can determine set of polynomials is closed under subtraction as well, because if we subtract these terms, use the same logic. It's still gonna be a sub n minus b sub n times x to the nth power, and so on, right? So it's gonna be the same logic, except you're gonna subtract the b sub n and b sub n minus 1 dot 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 dot. So it's still gonna be polynomial. But let's try to think about try number 3. Now, we want to know if monomials are closed under multiplication. So that means if we multiply monomial times a monomial times monomial, are we gonna get monomial? If it's not a monomial, if it's a polynomial, then it's not closed under multiplication. Monomial times monomial has to be monomial to be closed under multiplication. So check if there is any case that you can get something that's not a monomial. And if you can think of any, then it's not closed under multiplication. So think about this. Pause the video and come back when you're ready for answer. Okay, are you ready? All right, so if you think about an example, so let me give you a specific example. Let's say x is a monomial, right? X. And then another monomial is 2x. So if we multiply this, x times 2x, we're gonna get 2x squared. Oh, is that a monomial? Yeah, it is. Yeah. If you don't add them or subtract them, then it's gonna be a monomial. So what about other monomials? What about x squared? 2x squared and 3x to the 5th power. This is still a monomial, right? If we multiply them, 2x squared times 3x to the 5th power is going to be 6x to the 7th power. Is this a monomial? Yeah, it still is. What if we have different variable? Let's see if we have different variable with different numbers. So root 3 and then multiply by a y. So y root 3. And let's think about xy. And if we multiply these, y root 3 times xy, we are going to get xy squared root 3, right? Is this a monomial? Yeah, it's still a monomial. So is it closed under multiplication? Yeah, there is no way a monomial times a monomial will end up differently. Something that's not monomial, right? So yeah, yes, it is closed under multiplication. So let's write it as the product of 2 or more monomials will always be a monomial. Okay, so we can also prove it using the logic that we had here. So let a be a constant, any constant, that's a real number, and then a variable, x to the power of nth power. Okay, this is a monomial. And then another monomial, b times x to, let's do a different variable, y to the power of nth power. Okay, and then, yeah, it could be different powers, right? So nth power, right? And then you can multiply them, a times x to the nth power times b to the y to the nth power. And you can multiply a times b times x to the nth power, y to the nth power. This is still a monomial. So they're monomial. If we multiply them, it's still going to be a monomial. Okay? Because there is not going to be addition or subtraction that separates your terms. That makes your monomial polynomial. So let's explain this further. I'm going to add that the coefficient will be real because the real numbers are closed under multiplication. Okay, and the variable terms in the product will still have whole number exponents because the whole numbers are closed under addition. Okay. So here we have answered our question. So think about different examples and see if you can logically prove that they're closed under different operations. Okay, so that was example 3. We're going to continue with example 4 in the next video.